This is lesson 2, introducing proportional relationships with tables. And this is the table, the first activity. And notice that as you go from one row to another row, that is using what's called the scale factor. So 1 times 3, 12 times 3. 1 times 5, 12 times 5. But notice that you're using different scale factors. To scale something, it means to change both properties. You're going to change both the number of cases, you multiply that by the scale factor, and the second property is the number of rows, you multiply that by the scale factor. So they change in the same way. The other way to do these problems is to use what's called the constant of proportionality. So you multiply each number by 12. That's the constant that's related. So 1 times 12 equals 12. 3 times 12 is 36. 5 times 12 is 60. So just one factor when multiplying from x to y. So the factor is constant. It's the constant of proportionality. In this case, you're moving from one property, cases, to the other property, roles. You're not moving from one property to one property and a second property to a second property. This is from one property to the other property. And the second activity is more on comparing scale factor with constant of proportionality. And in this case, a scale factor is times 5 to get to 30. I moved the 3 and the 9 down here so you can see that it's right here, but I moved it down here so you can see that 9 times 5 is 45, 3 times 5 is 15. But on the other hand, you can use the constant of proportionality once again. So 2 times 3 is 6, 3 times 3 is 9, 10 times 3 is 30. In this case, what happens when you go backwards? You're given 45. The number of people is 45. So how do you get back to the number of cups of rice to use? You divide by 3. So if you start saying this relationship in words, the number of people is 3 times the cups of rice. So the number of people is 3 times the number of cups of rice. So y is 3 times x. So in math symbols, y is equal to 3x. Y divided by x is 3 to 1, or y to x is 3 to 1, which is 3, the constant of proportionality. And how you get that constant of proportionality in general is to take the y value and compare that to the x value, y to x, or y over x. There's a little drawing to get to 1 cup of rice for 3 people. This is the second part of this activity. And in this case, there's no convenient, after the first one, there's no convenient scale factor. So 6 times 5 is 30, 3 times 5 is 15. But after that, 6 times what gets you to 40, or how do you get to 56, or how do you get to 28? No convenient scale factor. But you can always use the relationship that's the constant of proportionality. So the number of people that get served spring rolls that you can serve the spring rolls to is 1/2 the number of spring rolls you have. So the number of people is 1/2 the number of spring rolls. So 6 times 1/2 is 3. 30 times 1/2 is 15. 40 times 1/2 is 20. But now if you go the other way, if the number of people that you can serve is 1/2 the number of spring rolls, it only makes sense that if you have the number of people, the number of spring rolls you need is 2 times that. That is the reciprocal of 1/2. So when you go the other way from the y column to the x column, you're going to multiply by the reciprocal. Again, how do you get the constant of proportionality? Y to x. And in words, if you say that y is 1/2 the number of units of x, then what you can say is that y divided by x is equal to 1/2, or y over x is equal to 1/2. And more directly in math symbols, it's y is 1/2 the number of units of x. So y equals 1/2 x. Making bread dough. Now I'm going to skip this and go to this next figure just for a second. So how do you get the constant proportionality, which is 10/8? Well, so 8 times what number? And it's right here, by the way. So from this table, 8 times what factor is equal to 10? 8 times what number is equal to 10? Well, several ways to get that, but one way is to think about, okay, how do I get rid of the 8? I'm going to divide by 8. So I'm going to multiply 8 times 1/8. That equals 1, so I've gotten rid of the 8. And then I'm going to take that and multiply by 10. So 1 times 10 equals 10. So the first step is divide by 8. The second step is to multiply by 10. So if you do that with one number instead of 2 steps, if you do that just with a single factor of 10/8, you really, as you operationally figure this out, you really divide by 8 first. 8 divided by 8 is 1, and then you multiply by 10. So 1 times 10 is 10, and soon you'll just learn to cancel the 8s. 8 times this 1/8 here is 8 divided by 8 is 1. These 8s cancel, and you're left with this 10. If you use the words, 10 is 10/8, the number of units of 8. So 10 is 10/8 times 8. It's kind of funny to say. 10 is equal to 10/8 of 8. So y is equal to 10/8 of 8. Y is 10/8 times x. So y is actually larger than x by a factor of 10/8. And the drawing of this, if I draw 0 to 10, 8's right here. Divide 8 by 1, that gets you down to here. So this 1 unit right here is 1/8 of that 8. So this is 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. 8/8 is all of this 8. And then if you go beyond that, this segment right here is 9/8. It's 9 of these pieces. Each of these pieces is 1/8 in this drawing. And then this 10th piece right here is 10/8. So 10, this 10 right here is equal to 10/8 of 8. Here is the 10/8 of this 8 equals 10. So 10/8 of 8 equals this 10. 10 is equal to 10/8 times 8. So y is equal to 10/8 of x. So 10/8 is the constant of proportionality. You can draw a double number line, convince yourselves that half of 10 is 5 and half of 8 is 4. So 10/8 is also this equivalent ratio to 5 to 4, or 5/4. Go back here just for a second. And so if 10/8 is the constant of proportionality, 20 times 10/8 is 25. So think about it. I went through all the steps here. I'm not going to talk you through that. But if you follow these steps, I start breaking these numbers up into parts that are easy to calculate in my head. So just one example, 13 times 10/8. That's the same as 13 divided by 8 times 10. Or 13/8 times 10. Well, 13/8 times 10 is equal to 13/8 is the same as 8/8 plus 4/8 gets me to 12/8 plus 1 more 8. The reason I want to do that, I know that 8/8 is 1. I know that 4/8 is 1/2. And then I'm going to add this last 1/8. And that all gets multiplied by 10. So you follow these steps down here. 10 times 1.5 plus 1/8 times 10. 10 times 1.5 is 15. Plus 10/8 is the same as 8/8 plus 2/8. I know it gets hard to say, but if you just write it out and think about it, you can see where this is now 16 1/4. 8/8 is 1. 2/8 is 1/4. So this is 15 plus 1 plus 1/4. If you multiply 20 times the reciprocal of 10/8. Now you're going to go in the other direction. 20 times 10/8 is equal to 16. 20 times 10/8, that's the same as 20 divided by 10 times 8. See how that works out. And then if you go the other way, 16 times 10/8, which is the reciprocal, you're going to get back to 20. So one direction, 20 times 8/10 gets you to 16. 16 times 10/8 gets you to 20. The units of flour is 10/8 times the units of honey. So whatever you have as far as the units of honey, the units of flour, the cups of flour, are going to be 10/8 times that much. So 10 divided by 8 is 1 divided by x. Gives you the constant proportionality of 10/8. For every 8 tablespoons of honey, you use 10 cups of flour. These are hard. This is just trying to get you into how to think about these problems. All right. The fourth activity. If you have 4 quarters, that is the same as 10 dimes. It's the same amount of money as 10 dimes. So the constant of proportionality is 4 times 10/4. You divide that 10 divided by 4. 4 times what factor equals 10? Well, 10 divided by 4 is equal to that factor, or 4 is 10/4. 10/4 of 4, or 4 times 10/4 is equal to 10. So the constant of proportionality is that 10/4. And that simplifies to 5/2. 10/4 is the same as 5/2. Let's try to see where I wrote that. Actually, I wrote it up here. So 0 to 10 and 0 to 4. Half of 10 is 5, half of 4 is 2. So 10/4 is equal to 5/2. So you have 6 quarters, 5/2 of 6, and I go through all the calculations on the next page. But just think about it for a minute. 5/2 times 6, 6 divided by 2 is 3. 3 times that 5 is 15. 5/2 of 14, 14 divided by 2 is 7. 7 times that 5 is 35. And then 1 quarter, 5/2 of 1 is 1/2 times 5, which gives you 5/2. Same as having 2 dimes and 1 nickel. And if you look at this down here, 5 dimes is the same as 50 cents. 5 times 10 is 50 cents. And 2 quarters is the same as 50 cents. 2 times 25 cents is 50 cents. So this makes sense. 5 dimes to 2 quarters is the same amount of money in each case. In words, the number of dimes is 5/2 times the number of quarters. So y equals 5/2 of x. So y is 5/2 times x. So y equals 5/2 times x. Here's all the calculations. And I would suggest that students go through some of these calculations, maybe all 4, take the time, go through step by step. Let's just pick out, actually it turns out that this second column right here, times 5/2 times the simplest form, the simplified form, is the easiest to work with. So let's look at 14, for example. 14 times 5/2 is the same as that 14 divided by 2. 14 divided by 2 is 7. 7 times that 5 is 35. On the other hand, 14 times 10/4 equals 14/4. So 14 divided by 4 times 10. Break up that 14/4 into 12/4 plus 2/4. 12/4 is 3. 2/4 is 1/2. And you have to multiply those by 10. That is going to equal 10 times that 3 is 30. And 1/2 of 10 is 5. Add them together, you get 35. It's hard to talk through. It's much easier to just work through the math and see if you can understand what's going on. So try to do that. Over here, I looked at these as, for example, 4 times 2.5 is the same relationship as 4 times 25 equals 100. So 4 times 2 and 5/10 is going to equal 10. So I made that same kind of calculation down that column. Problem number 1. The chocolate syrup is 3/2 times the cups of milk. So you have chocolate syrup and you have cups of milk. And notice that the chocolate syrup is 3 units, 3 tablespoons for every 2 cups of milk. So 2 times what value or what factor equals 3? This is the constant of proportionality. 2 times 3/2. So that 3 divided by 2 is the constant of proportionality. 2 times 3/2 equals 3. 8 times 3/2. So 8 divided by 2 is 4. 4 times 3 is 12. 10 divided by 2 is 5. 5 times 3 is 15. Alternatively, you could use the scale factor in certain places. 2 times 4 is 8. 3 times 4 is 12. But you can always use the constant of proportionality. And this is just going through thinking about what 3/2 means. Well, 3/2, 8 times 3/2 is 1/2 of 8. Second half of 8, which is 1/2 of 8 is 4. 2/2 of 8 is 8. And 3/2 of 8 is another 4, which gets you to 12. So it's 4, 8, 12. 10 times 3/2 is 5, 10, 15. 1/2 of 10 is 5. 2/2 of 10 is 10. 3/2 of 10 is another 5. So it is equal to 15. And that's what these words say in here. So I'll leave that for you to read. Scale factor up here is 4. Constant proportionality is 3/2. So the chocolate syrup is 3/2 times the cups of milk. So syrup, S, equals 3/2 of milk. You use more units of syrup than you use of milk. So you have to multiply by a fraction that's an improper fraction in this case. It's going to make the units get bigger. The number of units get bigger, sorry. So y is equal to 3/2 x. So the constant proportionality is 3/2. The units, tablespoons and cups. So you have 3 tablespoons per every 2 cups, or 3/2 of a tablespoon per 1 cup of milk. Yeah, right here. 3/2 tablespoons of syrup per 1 cup of milk. So 3/2 tablespoons per 1 cup of milk. Problem number 2. Red paint, white paint to make pink paint. So you can get the constant proportionality from the second row right here. So 7 times what factor is equal to 3? Well, that is 3 divided by 7, or 3 over 7. 7 times 3/7. 7 divided by 7 is 1. And then 1 times 3 is this 3 right here. So divide by 7, multiply by 3. So y over x, the constant proportionality, is going to be this y value divided by the x value. That's equal to 3 divided by 7. So y times 3/7 equals 3/7 cups of red paint to make the proper shade of pink paint. So the cups of red paint is 3/7 times the cups of white paint. So you use fewer cups of red paint to make the shade of pink. You use 3/7 of the amount of white paint that you use. So red is equal to 3/7 the amount of white. Y is equal to 3/7 x. So this y value on this side is 3/7 of this side, the cups of white paint. So anything over here times 3/7 is going to give you the amount of red paint that you need. Note that the amount of red paint is less than the amount of white paint. It is a fraction. The red paint on this side is a fraction, and it's a proper fraction in this case, of white paint. It gets smaller. So the amount of red paint is equal to 3/7 the amount of white paint. Problem number 3. This one's tough. What's the area of the park? You have a map that's 4 inches by 6 inches, and each inch is equal to 30 miles. Well, that means that 4 times 30 miles, this length in real life is going to be 120 miles. And 6 times 30 miles, this width in real life is going to be 180 miles. Well, to get the area, you could just multiply 120 times 180 equals 21,600 square miles. But think about what this is. I'm going to leave this for you to read through and think about if 1 square inch is equal to 30 times 30, or 900 square miles, and you have 24 of these square inches, then you're going to have 24 times 900 square miles, and that's going to work out to be 21,600 square miles. And if you take 120 and multiply it by 180, do a little bit of factoring. 3 times 4 for the 12, 3 times 6 for the 18, pull out the 3's, times 100, that's the 900, that's this 900 right here. And what do you have left? You have 4 times 6 left. So this factors out to be 900 times 2400 times 24 is equal to 21,600 square miles. This is the hard one. This is one of the hardest problems that you're going to be faced with in 7th grade. Understanding that to use the scale factor for area, it is the square of this. You multiply by the square of the scale factor. So to go from 24 inches to 6 inches, it is 1/4 of 24 inches equals that 6 inches for the area. So you're going to make this smaller brochure, smaller map that fits in a brochure. So instead of 24 square inches, you want it to cover 6 square inches. Well, that's 1/4 of this 24 square inches. So just divide this into 4 equal parts and focus on 1/4. Well, 1/4, the length this way is 1/2 of 4. 1/2 of 4 is 2 inches. So this length is 2 inches. The width this way is 1/2 of 6. So 1/2 of 6 is 3 inches. So this area, or the dimensions of this 1/4 of the 24 inches is 2 inches by 3 inches. And 2 times 3 gives you the 6 square inches. But notice that's 1/2. The scale factor is 1/2 times 1/2 this way. Well, 1/2 times 1/2 is 1/4. So the area is the square of the scale factor times the area. The area, of the scaled map is the square of the scale factor times the area of the larger map. So scale factor is 1/2 to get the area, and it's 1/4 the size. So it's 1/2 of 6 times 1/2 of 4. 1/2 times 1/2, which is the square of 1/2, is 1/4. 1/4 times 24 equals 6 square inches. This is tough, but use the square of the scale factor to figure out the resulting area. So the scale factor for the map is 1/2. Then the scale, now this gets hard. Now we're going to talk about the scale. It was 1 inch for 30 miles. But the scale gets doubled. It actually gets multiplied by the reciprocal of the scale factor. Because now we're taking this and we're making it smaller. This entire length still has to equal 120 miles. But that means that each inch now is 60 miles. So you doubled the scale. So 1 inch is equal to 2 times 30 miles is equal to 60 miles. So the scale will be doubled. Use the reciprocal. This is hard. So I made a larger drawing here. These are the dimensions, 2 inches by 3 inches. But remember, now instead of that 120 miles fitting across 4 inches, now it has to fit across these 2 inches. That means that each inch has to equal 60 miles. So you have 2 inches. 2 inches times 60 miles for each inch equals 120 miles. This is 120 miles. And you have 3 inches times each inch is 60 miles. So 3 times 60 miles is equal to 180 miles. So 3 inches times 60 miles per inch equals 180 miles. So these are the correct measurements. 2 times 60 is 120 miles, and 3 times 60 is 180 miles. That's the correct measurements for the park. But the key to this is to understand that the scale factor is 1/2, so therefore the scale increases by 2. It's doubled. To fit, you're going to fit that number of miles into a smaller length. So the relationship has to double. I have to get twice as many miles in that 1 inch. Problem number 4, you're going to scale a smaller polygon. Polygon P has an area of 5 square units, and it gets scaled up, and they want you to tell us what the scale factor is. What's the scale factor? So you're going to go from 5 square units to this larger image right here, which is Q. Well, if you figure out the area of this, there's a couple ways to do it. One is just to multiply 9 across down this way times 6 this way. 9 times 6 is 54, but then you have to subtract these 9 squares. That's 45. Or just count these. How many of these 9 square parts do you have? You have 5 of them. So 9 times 5 is equal to 45. Either way works. But then you have to realize that the area, so now we're going to move to area, which is square units. The area is the area of the smaller image times the square of the scale factor. So what's the scale factor you're going to multiply 5 times the square of the scale factor to equal 45. Why is it the square of the scale factor? That's all kind of right in here. Let's see, it's right here. The scale factor times the length times the scale factor times the width. So you're taking the scale factor and you're multiplying that scale factor times the length to get this length here. That same scale factor times this length to get this length here. Well, that is this scale factor times the scale factor times the length times the width. Well, this length times this width is equal to 5 square units. They give that to you. So then 5 times what value equals 45? 5 times 9 equals 45. So what number times itself equals 9? Another way to say that's what's the square root of 9? I don't know how much work you've had in that. So you can look at it this way. What number times itself equals 9? Well, it's 3 times 3 equals 9. So the scale factor is equal to 3. Hard problem. So 5 times 3 times 3. So it's 3 times these 2 units gets you to 6, and 3 times these 3 units gets you to 9. 3 times 3 times 2 times 3. Oh, and you have to subtract the 1, so that gives you 5 square units. All right. The last problem, what are equivalent ratios to within these 5 ratios? So start with the 4 to 7. Are any of these other ones an equivalent ratio to 4, a ratio of 4 to 7? Well, 16 to 28 is. Multiply 4 times 4, 7 times 4. And 20 to 35 is. 4 times 5, 7 times 5. Those are the only ones that work. The others don't work. 2 times 4 is 8, but 2 times 7 is 14. So you can't go from A to B. A to D. 2 times 2 is 4. 3 times 2 is 6. So you can't go from A to D. You try any of the other combinations, or 2 times 4 is 8. 3 times 4 is 12. D to B doesn't work. So the only ones that work are A, C, and E.